in our last lesson, we're sort of talking about different ways that we can represent relationships. We didn't get through all of them, so we're going to sort of finish off and recap what we do know. Excuse me, golly, it's been a week. And then we're going to move into starting to draw graphs. Now, I'll explain sort of drawing graphs as we go along. There are certain graphs where you will need to use a ruler to draw it. So please do make sure you do have one handy, but there are also ones that we draw freehand and are more sort of curves. So just bear it in mind. Okay, so if we have a look at what we have going on here, we have got a flow diagram in question A, and we know that this is one of the ways that we can represent a relationship between variables. Now, just as a reminder, we have got two important values that we work with when working with graphs or functions. We have an input value, which we often represent as x. Once we perform all of the operations we want to perform on it, so in this case, the times 10 and plus 15, we get an answer, which we call our output, and that we represent with y. And this is why we can write down an equation in terms of y equals something happening to x, because once I perform my operations on x, I'm going to get an output y. Right, so if we go and have a look here, I've asked you to write down an equation to describe the following relationship, and we're going to complete the table. So let's just look at this flow diagram. I've got a flow diagram that is saying to me that I'm going to take my input number, multiply it by 10, and then add 15. So if you guys would like to, you can put it in the chat, or remember, you're welcome to raise your hand to answer questions. Would anyone like to try, or anyone like to give a suggestion of what my equation would look like if I now write it as y is equal to, and then something to do with x, using those operations in my flow diagram? Okay, no one yet. That's fine. We're still warming up.
I guess.
Let's have a look. So what we're going to do is we're going to take our input. We're going to times it by 10. Oh, no. Okay. So if I times x by 10, we know that we get 10x. That is 10 times x, or x times 10, doesn't really matter. Then I need to take that product, or that thing that I've just multiplied, and add 15 to it. So I'm going to plus 15. And so what I've got is an equation that describes the flow diagram that I've got over here. Now, we need to be comfortable with equations, because this is sort of going to be the foundation on which we build our graph knowledge. Okay, Kakliso, do you have a question, or do you want to add to this? Okay, no problem. Alrighty, guys. So essentially what we need to do is, once we know what relationship we're working with, whether it's using a flow diagram or whether it's using an equation, if we want to eventually draw graphs, which we're going to get to today, we need to have some input and output pair values. And we'll chat about this a little bit more in a second. So I know that I've got my inputs. These are all of my x's. And I've got my outputs, which are all of my y's. And remember, the output depends on the input. I can only get an output if I know what the input is. So what I mean by that is, your x variable is essentially the independent variable. And so we can pick values for x to substitute into our equation in order to find y. So for example, if I said your input was -3, we would go and say, okay, well, to get my output of y, I would take 10, multiply that by -3, and I would add 15. Now we know that 10 multiplied by -3 is -30 plus 15, and -30 plus 15 is -15. So the corresponding output when my input is -3 is -15. And so by applying the specific rule I have, or the equation that I'm working with, or the flow diagram, or whatever it is, I'm able to take an input, do the operations to it, and get my output. Alrighty, so let's try another input value. Let's say I now said my input value was a -2. I'm going to give you guys all a second or two to give it a go and try and work out what your output value is. You can put it in the chat or you are welcome to raise your hand, but I would like to know what the output value is when the input is 2. Okay, Batabile, do you want to tell me?
Yes, ma'am.
Yes.
I think it will be okay. It's 10. I think it will be -23.
Okay, where did you get, let's just double check your substitution. So this would be y is equal to 10 times -2 plus 15. Do you agree?
Yes.
Okay, so -2 times 10 is a -20. And what's
Yes.
-20 plus 15?
It's 35. It's -35.
-5, because remember, I'm going from a -20 and I'm adding 15. So my negative is actually getting smaller because I'm adding onto it.
Oh, yes, ma'am. Thank you.
Good, well done. Alrighty, guys. So just remember, when working with those negatives, we do need to be careful. If you are going to substitute in using your calculator, just remember that your calculator will always do the multiplication first, which in this case we do want, but do just bear it in mind. Your calculator doesn't always do BODMAS correctly. Alrighty, let's try another one. I still see some hands up. I'm assuming, can we just do this? If you've got a question, please leave your hand up. If you don't have a question, lower it. We're going to do more, so there'll definitely be more opportunity for you to give an answer. Right. Let's say my next input value was, 0. So I'll give you a second to think about it. What will my output value be if my input is 0? You can put it in the chat. You're welcome to raise your hand. Leobona, what do you think?
I think it's 15, ma'am.
And how did you get that?
I times 10 by 0 and I got 0.
Good.
And then I added 15 to 0, ma'am.
Excellent. Okay, so guys, remember, whenever we times anything by 0, we get 0. So exactly as Leobona said, 10 times 0 is 0, and then 0 plus 15 is then 15. So we end up now with a positive 15. Right, I'm going to give you a couple more, and I'll give you a second or two to work them out. So my next inputs that I want from you is an input of 1, an input of 4, an input of 7, and let's do an input of 11. Right, so I'll give you all a second. If you wanted to number them on your chat, we can call this A, B, C, D. So I need 4 answers from you. I'm going to give everyone a chance to just give it a go, and then I'll start taking some hands. But again, you're welcome to pop it on the chat as you get your answers. All right, guys, I'm going to give you another minute or so. Remember, we're substituting in those input values to find y, to find our output value.
Yeah, doing really great, my Pebs. Let's continue. Remember to write your answers down on the paper like this. When you give us answers, you give us what you have calculated already. Let's go, my pebs. Y'all are doing really good.
Okay, Amber, do you want to give us the first one? So what is the output when our input is 1?
By by 1, I wrote that 10, it will still be 10 plus 15, and it will give me 25.
Excellent, well done. So our output here, guys, is 25. Exactly as Amber said, when I take 10 times 1, I've still got 10. And so then I'm just adding 15 to that 10. Excellent, Amber, well done.
Thank you, ma'am.
Alrighty, our keyword, do you want to give me what my output would be when my input is 4?
Yes, ma'am. The
Yes.
answer is 55.
Good, do you want to explain it for us?
I substituted, so I put 4 in the bracket.
Good.
And I said 10 bracket 4 close bracket plus 15. And then
Good.
I got the answer of 55.
Excellent. Excellent. Well done. So guys, 4 times 10 is 40. And then plus the 15, exactly as our keyword said, is 55. Right, Lesejo, do you want to give me the output when my input is 7?
Yes, ma'am.
Yes.
Ma'am, you say 10 times 7 plus 15, it's going to be 70 plus 15, it's going to be 85.
Excellent. Well done. Right, Lesejo explained it very nicely there. I don't think I need to repeat anything. Lungile, tell me the output when my input is 11.
125.
Excellent. Do you want to explain it for us?
Yes, ma'am.
Tell me.
I said 10 times 11 equals to 110 plus 15, and then I got 125.
Excellent. Well done. Nice, guys. Very, very nicely done. Okay, so everyone with the hand up, if you have a question, you can leave it up, but if you don't have a question, please do lower it. We're going to do lots more examples, so there will be chances for you to give answers as we go along. Right, I'm assuming these hands are for questions. So Lesejo, Nomi, Kanyo, and Amber, I'm assuming we all have questions. If you don't, please lower your hand. Okay, Lesejo, what is your question?
I'm nothing, ma'am. Sorry, ma'am.
No problem. Kanyo, do you have a question?
Ma'am, can you please do 4 again? The sum.
The sum for 4.
Yes, please.
Perfect. Cool. So guys, if we just quickly look at 4 again, 4 is my input. I'm just going to write it down here. So I'm saying 10 times 4 plus 15. Now we know that 10 times 4 is 40. And then we're going to add 15 to that. And so 40 plus 15 gives me 55. Right, so through my multiplication and then my addition, I'm getting 55 as my answer. Kanyo, I hope that makes sense. Cool.
Yes, it does. Thank you.
Good, well done. Amber, do you have a question for us?
Yes. For the first one, you gave us negative 15, which I tried working it out by myself, and I realized that it came with an output of negative because the question is negative 3, and there's no a positive. So I was wondering about the positives that didn't come out a negative, because I'm very confused about that.
Okay, so just to make sure that I'm understanding, are you asking me why all of these positives don't have negatives here?
Yes, ma'am.
Okay, cool. So the reason that, let's sort of go from, let's say I'd given you an input, and I'm just going to add it on the end here, of -1. So if my input, so my X was -1, when I substitute that in, I'm getting 10 times -1 plus 15. Now 10 times -1 is -10. And now I'm adding on a number that is greater than 10. And so what that means is, again, if I just scroll over here, if I think of this in terms of a number line and I'm sitting, say, at, oh gosh, I really made work for myself, at -10. Okay, I do apologize. Ooh, maths. 5, 4, 3, 2, 1, 2, 3, 4. Okay, right. So I'm now sitting at -10. I am adding on a value that is bigger than the 10. So now when I add my -15, my positive 15, I'm moving up my number line to where the numbers are more positive. And as I get to adding on positive 15, I'm getting now to a positive 5. However, when I was working with, say, the input value of 2, let's just make this a bit smaller so we can still see everything. My input value of 2 took me to -20, as we can see over here. And if I say -20 plus 15, I'm actually now adding on a value that's still a little bit smaller than the negative. And so it's not going to take me all the way out of the negative values, but it takes me to a much bigger, okay, that sounds a bit contradictory, but it takes me to a negative value that is further up my number line, because I'm still adding on. So I'm still making it less and less negative, but I don't quite get to positive numbers. And this goes exactly back to working with integers. So now when I get to inputs that are positive, because everything in my equation, as you mentioned, is positive here, it's a positive 10, it's a positive 15, I'm not going to have any negatives that I'm working with. I only get negatives when I'm working with values or input values that are from -2 towards -infinity. We've shown that -1 still gives me a positive, and that is because I end up adding a value that is actually bigger than the negative. So it takes me into the positive integer region. Okay, so if that didn't make sense, please do pop a question on the chat, but hopefully that makes a little bit more sense. But at the end of the day, it comes down to the fact of, if I'm adding more than what the negative is worth, I can get it to a positive. If I'm not, then it's going to stay negative. And I like to think of it as a number line sort of situation. I often find that's quite helpful. Alrighty, guys, so if you need, take a screenshot of this, and then we're going to have a look at our next one. Just because I'd like to make it a bit bigger, so we're going to lose some of this writing. Right, so our input number, or rather our output number, is equal to the input number times 7 plus 10. So you can obviously, by all means, work with something like that. But let's try and write an equation for ourselves. So if we wrote it as y is equal to, who wants to give me or would like to try what the equation would be? So when I say equation, guys, I'm talking about this thing that we wrote in the blue block over here. What would the equation now be for this relationship? Lesejo, do you want to tell me?
Yes, ma'am. It's going to be y equals to 7x plus 10.
Excellent. Well done. So we've got y is equal to 7x plus 10. And so this is now the relationship described as an equation. So now we want to fill in some inputs and some outputs. So we know our inputs are x, our output y. I'm going to give you a couple. I'm not going to fill in all of these blocks because I was a bit eager, but let's do those 4. So I'll give you a second to give a try of those. And then I'm going to ask for some hands to give me answers. I hope I'm saying your name right. Issa Leona, if you put your hand up, I'm happy to give you a chance for giving me values here. And if I'm not saying it right, you can also correct me. Right, Monde, yes, exactly. So what we want to do is we now want to take each of these inputs, so each of these x's, and we want to substitute it in place of this x and find out what our corresponding y would be. Okay, so guys, the whole sort of thing that we're going to use here is essentially substitution, because if we know what X is, we can substitute to find Y. Why are you fighting? Oops. Okay, I'm seeing lots of hands. I'm hoping this means we're at a point of being ready. Normie, do you want to give us the first one? So what is the output when our input is -1?
Ma'am, I just did the equation. I don't understand the output.
Okay, what aren't you understanding about the output?
Ma'am, aren't we supposed to be saying -1 times 7 plus 10 equals -7 plus 10 equals 3?
Yes, exactly. That's exactly what I want from you. So just to explain what Normie said, we've done exactly what has just been described. Y is equal to, and then we take the input of -1 and replace it with the X. So we're substituting. So that means we've got a -7 plus 10. And so exactly our output here is +3. So through substitution, we're able to get our value here. Alrighty, so let's see. Oh, sorry, guys. Njabulo, tell me the output when the input is 0.
Oh, sorry.
What's wrong?
Babe, I'm sick.
Oh, it's all right.
Oh, okay, so it's gonna be 7, substitute 0 plus 10. So
Good.
7 times 0 is 0.
Good.
Plus the 10, it's 10.
Excellent. Well done. Perfect. I hope you feel better. Okay, guys. So again, remember, the second we're timesing anything by 0, we're going to get 0. Okay, Timbela, do you want to give us the, oh, golly. Okay. You still there?
Yes, madam.
Okay, would you like to give us the output when our input's 3?
Yes.
Okay, tell us what it is.
Y is equal to 7 times 3 plus 10.
Good.
And 7 times 3 is 21.
Good.
Plus 10, 31.
Excellent. Well done. Right. So exactly, guys. 7 times 3 is 21. 21 plus 10 is 31. Okay. Oh, guys, so many hands. This is awesome. Bocello, do you want to tell us the output when our input is 5?
Yes, ma'am.
Okay, tell me.
We're going to say 7 multiplied by 5 is equals to 35.
Good.
Plus 10
Good.
is equals to 45.
Excellent. Well done. Right. So guys, 7 times 5, exactly as we said, is 35, and 35 plus 10 gives me 45. So those are my corresponding outputs. Right. I do see lots of hands. Don't stress. We're still going to do more. So there'll be more opportunity. Please lower your hand if you don't have a question. But if you do have a question, you can obviously leave your hand up and I'll answer it. Just giving everyone a second. So our Kiwe, Matlongolo, Islona, and thank you. Hello. Is that right?
Yes.
Okay, so those are 4 hands that I still see up. So I'm assuming these are questions. Our Kiwe?
Ma'am, no, I don't have a question. Sorry.
Okay. Okay, so we've got hands disappearing now. Oh, okay, I'm going to say it wrong again. Cajelo? You can correct me.
That's right. It's Cajelo. That's right.
Cajelo. Okay,
Yeah.
I'm getting it. What is your question? No? It's Leona. Do you want to tell me what your question is, or do you have a question?
Yes, ma'am, I have a
Yes.
question.
Yes.
Ma'am,
what is
can you please re-explain the rule, ma'am? I'm getting a little bit confused. Like my mind is not in maths, ma'am.
Okay, so when you say please re-explain the rule, do you mean this y equals 7x plus 10?
Yes, ma'am, I mean that one. Like the
Okay.
calculations, I can do them. It's just that the rule, it can distract me sometimes mid calculation, ma'am.
Okay, cool. So the rule I'm getting from this sort of statement over here, it's telling me that my input number, which is x, is being multiplied by 7, and then I'm adding 10. So that's all I'm doing here. This is the x times 7, and then I'm adding the 10. So all I'm doing is I'm writing an algebraic equation to represent essentially the words that I've written down. Whilst we do need to be able to do this, as long as you times each one by 7 and add 10, it's absolutely fine. Okay, so whilst it is important to get the algebraic equation, just for now, just being able to do the calculations is really what I am focused on. Okay, so I hope that makes sense. If it doesn't, you're more than welcome to pop another question on the chat. Right, guys. Okay, Kia, do you have a question for us?
Yes, ma'am, I have a question. Ma'am, for the rule, the x7 plus 10 might be a bit confusing for me because I prefer the x behind the 7, not in front of the 7.
Yeah, so I definitely agree. So if we want, we can definitely say 7 times x and then write it as exactly as you say with the x at the back.
Yes, ma'am. Thank you.
Good. Okay, right. So, my brain, right. Guys, again, I know that we need breaks. I will always do a break, but I'm also not going to stop people from asking questions. Like, this is the whole point of these lessons. So we are going to take a break now. Please don't worry, like fully aware that we're not going to stop people asking questions. It's important that people ask questions that we can all learn. I'm going to stick here for a second in case you would like to take a screenshot of this before I move to our brain break. And then I will scroll down and we can have our brain break. Alrighty.
You guys did well, my peeps. So proud of you. You did really well.
Okay, so here's our brain break for the day. And I quite liked the way we did it on Monday, where we did do it on Monday. Hey, Yolanda, I'm not going crazy.
Yes, we did.
So we are not going to help at all. I'm going to let you guys sit with this, and we are going to wait for the first person to put an answer on the chat, and then we will go through it. So remember, guys, what you're trying to do here is you're trying to work out the value of the zombie, the, I don't know, balloons, and the sucker in order to get the value of this final expression over here. Right, so look carefully, think about, are there one, are there two of them? And then we want to get the value over there. I already see some hands, but like I said, we're going to give everyone a chance to get a final answer. You can put your steps on the chat so that as you go along, hopefully you can help people as you're working it out, and then we'll wait for a final chat. A final answer on the chat, and we can check.
Exactly. We want to see who's our winner, my peeps. So let's go. You better do it on your paper. Like this, you know that you're going to get it first. So we don't want the first step. We don't want the second step. We want the answer. What is the final answer? Let's go. This should be fun, my peeps. So remember, for all our newbies, don't worry. If you don't get it, you will eventually, you know, as you attend more classes with us, you will get the vibe on what we do on our brain breaks, which is just some fun things that we actually do. So even if you don't get it, please do not stress. As long as you get your maths right, that's it. And yeah, we're just really having a lot of fun by seeing who can get this answer first. Actually, let me also do it. I don't know what is the right answer.
Yeah, I'll send it to you now. Sure, as long as I can do maths. Because we saw last week I couldn't. Oh, yeah, yeah. Okay.
Let's go, my pebs. You should be able to figure it out. What is their final answer? Let's go. Don't fall for the trap. I can see that, you know, the end result had some trap over there that if you don't realize it, you might calculate everything wrong. So do not fall for the trap, my pebs. Don't
like
fall
I
for
did
it.
on Monday. I appreciate Amanda being supportive of my mistakes on Monday, though. Very appreciative.
I haven't seen the right answer yet on the chat. As soon as we see the right answer, we'll definitely let you, my pebs, know. So you have to check your calculations. If they're right, we can do this. Definitely use your calculator. Maybe that will help. And remember that BODMAS is our friend. My pebs, BODMAS is our friend. That's what you need to remember. So I see Lorraine's hand. Lorraine, you need to put your answer on the chart, because if you don't put your answer on the chart, we cannot give you a chance to whoa, Teacher Sam, can you see him? Paul got it right.
Well done, Paul.
Well
and
done.
Yabona.
So our winner is, oh, I see Kwanda also. Actually, Kwanda was first before. No, it's
Nice, guys. Well done.
Explain. Yeah, Mpo should raise your hand and you can explain. I see Farid also got it right. Ashley also. Okay,
Right.
Amber wants to explain because Amber says she got the answer first. Amber, would you like to explain to us?
Yes.
How did you get the answer?
Okay, it is my first time doing this, so I've noticed about the 4 balloons and 1 lollipop and 1 snow globe, and I calculated, and I don't know how I did it, but I tried doing 40, which for the 4 balloons, plus 10 for 1 lollipop, and times 10 for the snow globe, which got me to 140.
Okay, so careful, the answer isn't 140 here. You've got some of those values correct. I definitely agree with the snow globe zombie looking thing, whatever it is. But the balloons, just be careful of that value there. And we're close with the lollipop. I see him pause here, hand, so maybe we can get a little bit of help here. And Paul, do you want to help us out?
Yes, ma'am. So I times 9 times 10, which gives me 90. So I got 14 plus 90, which gives me 104.
Okay, good. So Paul, can you walk us through step by step? So in the first one, what did you do?
I multiply first 9 times 10, which gives me 90.
In the first one, I mean the first step of the brain break. So these...
It's 20 plus 20 plus 20, which gives me 60.
Good, thank you. Now, what is one of these zombies?
It's 10.
Good. So that means these 2 balloon-looking things are?
They're 7.
Good, because 10 times 7 is 70, plus 10 gives me that 80. Perfect.
Yes.
So now I know that's 7. So what are my lollipops?
9 times 9.
Excellent, which is 81 plus 7, which gives me 88. So
Yes.
now I've got a double balloon situation here. So what is the value of that?
The double balloons are actually 14.
Excellent, well done. And then which operation do I do first? Do I do
multiply
Good.
first?
Good. So we do 9 times 10 first, which is 90.
Which is, yes.
Oh, gosh. And then
We add,
good.
which gives me 104.
Excellent. Well done. Nice, guys. Okay, so hopefully this makes a bit more sense now. And remember, this is not like the serious maths. This is just something fun for you to have a try of. Oh, sorry, is it a mummy? I didn't quite know. I actually just looked at it and I also thought it was a snow globe looking thing initially. So a mummy, not a, what was I calling it? A zombie. Right, guys, but that is our brain break. Well done to everyone. I hope it wasn't too tricky. I hope we're all happy. Batabile and Lawazi, I still see your hands up. Do you have questions or is that by mistake? I'm going to give you a second or two to decide. Okay, Batabile, do you have a question?
Yes, ma'am.
Yes.
My question is not based on what you're doing right now.
Okay.
But then
well, what is it based on? Because we're doing graphs at the moment.
Ma'am, I was up because ma'am, I'm quite new here. So I wanted to ask that at my school we're doing Cartesian graphs. Cartesian planes, ma'am, I mean. So and I quite don't understand them. So
okay, so like I said at the beginning, if you join a little bit earlier, so if you join like 5 minutes earlier, we're more than happy to help with questions outside of what we're doing. But when we're in the lessons, we're going to focus on what we're currently doing. But you can also go onto Watobe's website and see if you can find videos there for the Cartesian plane, which pretty sure there are videos there. So hopefully you can also get a bit of help there.
Thank you, ma'am.
Sure. Alrighty, guys. So let us, excuse me, let us get into sort of this whole sort of graph concept. I'm going to say this again. We are focusing currently on graphs. If you are on another section that you are struggling with, please go have a look on Watobe's website because there are videos there. I am still going to do area, perimeter, and Pythagoras. That is coming up in our next section and we will deal with it then. Or you join the lesson 5 minutes early and you're welcome to ask me whatever questions you want and I will help you. But right now we're focused on graphs. I know I skipped C, but it's very much the same as what we were doing. I want to move on to this because this is the fun stuff. All right, don't stress, guys. We got this. So like I said, being able to work with equations is a very important part of graphs because from sort of like grade 9, we will really only ever deal with equations when we talk about graphs. And so we need to be comfortable with it. So once again, these are like sort of what we did in question B, where I've got some words for you. And what we want to do is we want to write the equation. So this first one says, the output value is the input value plus 4. Now we know that the output value is y. We know that the input value is x. And so if we know or want to get an expression for the output value, I have just told you that this would be the input, so x plus 4. And so just by translating the words into an algebraic equation, I've got an equation. Now this will eventually become a graph that we're going to draw in a second. So who would like to have a go for B? It says the sum of the input value and 5 is multiplied by 3. That will give us the output. I didn't put that in there, so let's just put it in. Gives us the output. So it's y equals, and then we want to write an expression for what is happening to x. And x, remember, is your input. we're taking the sum of x and 5 and we're timesing that by 3. Can anyone help me with what does sum mean? Lesejo, do you want to give it a try?
I think it's y equals to 5x times 3.
Okay, very close. 5x, remember, means 5 times x. And as people were saying on the group, if I'm saying or talking about the sum, I'm talking about addition. So if I want the sum of 5 and x, do you agree it should be 5 plus x?
Oh, yes, ma'am.
Good. So we would have 5 plus x or x plus 5. And that whole thing then needs to be multiplied by 3. Now we can write it like that. It really doesn't matter. Or we can write this as y is equal to, and I know some people like to put the coefficient in front of the bracket, which is absolutely fine. So x plus 5 is the input value and 5 is the sum. And then times the whole thing by 3. And we get our equation. Again, this is an equation that describes a relationship. Now we know if we wanted to, we could distribute that. You can if you want to, it's really not going to make a difference. If you want to distribute, you could write it as y is equal to 3x plus 15. But according to the words, that is the expression that I have here. Amber, do you have a question or do you want to try the next one?
I want to try the next one.
Okay, so I'm just going to read it and then you can give us the answer. The input value is multiplied by 3 and then has 2 subtracted. So what do you think, Amber?
I would think is y equals to x times 3 minus 2.
Excellent. Can I write x times 3 as 3x?
Minus 2.
Good. Okay, guys, so we know that x times 3, we can just write as 3x. And then we're taking that and we are subtracting 2. And that is giving me my relationship between our input and our output there. Right, I'm just going to make this a tad smaller because we've got one more and then we can get it all on one page. The last one says the output is the input value squared. So who wants to give this one a go? Carly, what do you think? Oh, that clicked.
I think that it's you square the y.
Okay,
and
so
and then you square the x as well.
Right. So remember, yeah,
the output is y and the input is x.
Good.
The input is x, and
Good.
you should square that too.
Good. So the input value is squared. So we just square the x and that will give us the output value. We don't have to square both. It is just the input value squared, but very well done. We have to actually raise it to an exponent. Well done, Carly.
Thank you, Miss.
Okay, so guys, this is all leading us to being able to draw some graphs. Now, we're not going to get through all 4 of these now. Sorry, Silona, I clicked buttons. I don't know what ended up there. We're not going to get through all 4 of these today, but we've still got quite a few more lessons to get there. So what I want to show you is how this can now translate into a graph. We'll probably only get through maybe the first one, maybe the first and second one, but it's not a stress. We'll just carry on Monday. And this is sort of where we now need to be comfortable leading into graphs. We do a lot of graphs in maths, and so we have to be comfortable with this stuff. So take a screenshot of, yes?
Ma'am, when is the next class?
On Monday.
Oh, usual time, ma'am.
Yes, same time as all the time.
Oh, thank
That
you,
made no
ma'am.
sense. Sure. Right, so guys, take a screenshot of this if you want. I'm going to rewrite all of these equations. So if you don't take a screenshot, don't stress too much. But let's have a look at how we can get some graphs. So if I take the very first equation that I had, and that was the y equals x, and I've already forgotten what it was, plus 4. We can have a table of input and output values that we can find. So we don't really have to do so many blocks. Let's just pick a couple. Let's say I've got -2, 0, and 3. Guys, how you screenshot is very much dependent on your device. If you're really struggling, what I suggest is grab your phone and just take a photo of the screen if you don't know how to screenshot. Often what you can do is you can click print screen if you've got a laptop, and you'll just have to copy that over into a document. But yeah, it depends on what device you're using. Right, so guys, there are my inputs. -2, 0, and 3. So hands up, who wants to give me my output when my input is -2? Okay, I'm going to take Lorraine's answer off the chat and Amanda's answer off the chat. If we take -2 plus 4, we get a +2. Lawrence, I see your hand. Lawrence, would you like to give us the output for the input of 0? Lawrence, you there? Okay, Lawrence, your sound is a bit delayed.
Yeah, guys, I think Teacher Sam will do this one for us because of time. So, Lawrence, you can put your answer on the chat.
Alrighty, guys, so those are our outputs. Okay, Lawrence, I need you to just mute yourself for me because I don't know what's happening there.
Yeah, I also can't mute him. I tried.
Right, so guys, this is our outputs, and I saw that coming through quite a bit on the chat, and that's awesome, so well done. So where I'm going to end off is just leaving you with a thought here. And the thought is, if we've got these sort of pairs happening, the pairs that we have is an X and a Y pair. Now we know that if we've got an X and a Y pair, what we actually have is a coordinate. And if we've got a coordinate, then what we can do is we can now translate that onto a Cartesian plane, which is that sort of set of axes over there. And this is where we're now going to eventually head with our last few lessons of actually taking these coordinates, putting it on a Cartesian plane and drawing the graphs. And so what we need to realize is that we're now starting to make these links with all the sections that we've done, in that X and Y values translate onto a Cartesian plane.